In section 10.7, we're looking at our equations of circles and eventually graphing the circles. Before we look at the equation we're going to use, we just want to kind of see a background to how we're actually going to get to this. So, if we let xy represent any point on a circle with the center at the origin and a radius r. Let's start with that. So, I have my xy axis, I have my center is at the origin, 0, 0. And I'm going to pick a point, doesn't matter where on the circle, and just think of it as xy. Doesn't need numbers, it could be anywhere on the circle, but there's some point here, x, y. Now, if I asked you, well, how would you get to that point if you're at the origin? How would you graph it if I gave you the coordinates? You'd likely go over on the x-axis the amount of x value, and then you would go up its y value to that point. Now, we also have in this, to this point, since it's on the circle, its radius, which we're going to call r. Now, by that, since that x and y are perpendicular to each other, we get a right triangle with x, y, and r giving us what it says here, that Pythagorean theorem, x squared plus y squared equals r squared. So, let's maybe think of another point. Okay, so let's think of a point out here. It's still xy. It's a new xy. Okay, now this one, I still have a y value, I still have an x value, and I would also have a radius. Now, I could solve this one by Pythagorean theorem. Now, even though this would be negative x, since I square it, it's going to be a positive, and it would still work out to give me the radius by Pythagorean theorem. So I've drawn two separate triangles. They don't look alike. They're not near each other. But think for a second that this radius is the same. So as long as this point is somewhere on the circle, the radiuses will match. Even if I went and drew it down here, maybe as another xy, or something over here as another xy, I would have this common link between them that the radius is always the same. So no matter where that point is, as long as it's on the circle, those x and y values combine by x squared plus y squared to give me r squared, which is Pythagorean theorem. So this is our start of it. This is the equation of the circle with radius r and the center at the origin. So it's the collection of points, which we talked about back in section 1. It's a collection of points that make up a circle, all those points that fit to Pythagorean theorem. Now, before we get too happy about this, we're not always going to be at the origin. It's going to shift. But Pythagorean theorem will be used here. It's that idea behind it to help us give it the circle. Now, what also helps us is kind of the foundation we used before we got to Pythagorean theorem. So, let's start off. To find the equation of any circle, you need to know two things: the radius and the coordinates of the center. If I was to describe a circle on a graph to you, I'd tell you where the center is and how big the radius is. That's some common link that I can use to describe any circle. Now, if the radius is r and the center is hk, should have a comma there, then to find the distance between a point on the circle, xy, still that xy somewhere on the circle, and our center, hk, we would use r. Well, let's take a second here and look what we have here. So I've now shifted it from over here to up here. My center is not at the origin anymore. It's now hk. I have my radius, and I have xy, still some point on the circle. If I kept with that same idea as we talked about earlier, I have a right angle there, and I can use Pythagorean theorem. But I've kind of rearranged it to now look like this. Well, this actually looks very similar to something we've talked about before. If I change the letters, I get the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. So we've now taken that distance formula along with Pythagorean theorem, which really is just another form of the distance formula, to kind of help us with the graphing the circle. Now, if we square both sides, we get our standard equation. And that is x minus h squared plus y minus k squared equals r squared. But make sure you know that the center is hk and the radius is r. So it's finding that points on the circle that it's some radius away from our center, no matter where it is. This will work on any graph we look at of a circle. It doesn't have to be at the origin, because we have that h and k as our center. Now, if I wanted to still look at the origin, I can just make these 0, and it becomes x squared plus y squared equals r squared, which is fine, that works, but we won't always have it at the origin. Now, before we get into these problems, just notice a couple things. If I had this center, and I had some numbers here, and I plugged them in, do you notice how I change the sign? It becomes x minus h, y minus k. So if this was 1, 2, this would be x minus 1, y minus 2. If this was negative 1, negative 2, it would become x minus negative 1, or x plus 1, and y minus negative 2, or y plus 2. So look for that. Keep that in mind. We're going to be changing the sign. The other thing is our radius is squared in the equation. So if I had a number for a radius, I'd have to square it to write in the equation. And if I wanted to take it out, I would have to take the square root of it. So things to keep in mind as we start looking at these problems. So there's our equation up there. So let's just write the equation given some values. So my center is 0, 0. My radius is 2.5. So this is h, this is k, this is r. So I'm going to say x minus 0 squared plus y minus 0 squared equals 2.5 squared. Well, this simplifies to just be x squared. I get y squared equals 6.25, and there's my equation for that circle. Center at 0, 0. I didn't add or subtract anything from x or y, so it's at 0, 0. And my radius squared is 2.5 squared. Next one, I have negative 2 and 5, so that's hk, and r is 7. So I'm going to say x minus negative 2 squared plus y minus 5 squared equals 7 squared. Well, minus a negative becomes positive, so x plus 2 squared, y minus 5 squared equals 49. So negative 2, 5 becomes positive 2, negative 5 within the equation. Then if I was going to take them out, I would do the opposite again. Okay, if we look at this one down here, now we're talking about, this is a little different way to look at it. Let's say I have the center at negative 1, 3, and a point on the circle, basic sketch here, at negative 5, 6. So that's kind of saying the circle's going off in that direction. I need to write the equation for the circle. Now, I said earlier you need two things to write the equation for the circle. You need the radius, and you need the center. So far, we know the center. We need the radius. Typically, though, we don't get a point on the circle, so we're going to use that to help us find the radius. So let's first write our equation out. I know my center is negative 1, 3. I can plug that in. That's going to be negative 1 plugged in would be plus 1. And 3 becomes y minus 3. Now I need r. Right now I have a point on the circle. Now the radius is that distance between the two. So I could go off and use the distance formula here and find the distance. That would be my radius and plug that back in. But I could also do something else, because we said that xy is a point on the circle. Well, that's a point on the circle. So if we plugged in negative 5 and 6 in for x and y, solve for r, we would then have our radius and we could write the equation. So I get negative 5 plus 1 squared plus 6 minus 3 squared equals r squared. That becomes negative 4 squared plus 3 squared equals r squared. 16 plus 9 equals r squared. 25 equals r squared, and r equals 5. So our radius is 5. Now to get my answer, I plug it back into this equation, and it becomes x plus 1 squared plus y minus 3 squared equals 5 squared, which is 25. Okay, our last two, we're going to take our equation now and identify the parts. So instead of actually writing hk, we're just going to write our center. Okay, so here's my equation. I need my radius first. For my radius, I take the square root of this value, so it's 4. For my center, I take the opposites of these, and I'm going to call it 4, negative 3. So 4, negative 3 is my center. I have a radius of 4. Next equation, x plus 8 squared plus y plus 5 squared equals 121. I take the square root of that to find my radius. That would be 11. My center, I take the opposites of those. It would be negative 8 and negative 5 for my center. So my radius is 11 and my center is at negative 8, negative 5.